morning. Okay, let's continue with section 9.2, which was using solving 9.2, solving quadratic equations by completing squares. So we were we were trying to complete the square where we have the a minus or plus b square, then this is equals to a square plus b square plus 2ab, and a minus b square equals to a square minus 2ab plus b squared. So we were completing the squares to make a perfect trinomials, and then we write the results in binomial squared form. So let's do one example, and then we come to the let's do one example on binomial expression, and then on quadratic expression, and then we now come to using the completing squares to solve an equation, quadratic equation. So, for example, if we are given w square minus 3w all over 2, now complete the squares to make a perfect square trinomial. So, we discussed on how we can complete the squares of this one. Yeah. So where we say it is similar to what? To the a square minus, because of this side here. Okay. So we can write as w square minus 3w all over 2. Now, so we can see a will now be what? A equals to what? The w, right? And then we now look for b. So what will be our b? So what will be our b? Now, looking at here, then our b will now be, because this is 2ab, yes? So our b here will now be plus here, 1 all over 2. You remember the one for 6 that we were doing last week? So it will be 1 over 2 times now the b, and that b is the coefficient here. So half of this coefficient here. So half of 3 all over 2 there. And then you do what? We square. And that also we must consider this side over here. So you should also consider the side. So half of the coefficient of this, which is the b. So half the coefficient, and then you do what? And then you square. Then you square. So finally, our equation will be w square minus 3 all over 2 w plus. So this will be minus 3 all over what? All over 4, and then you do what? You square. Minus 3 over 4, and then you square. So finally, our our completion of squares will now be, you take this, which is the W, which is the same as A. Now our B will be this. Our B will be minus what? Minus 3 over what? Minus 3 all over 4. Sorry. Or B minus 3 over 4, and then you do what? And then you square. And that is our solution there. You want me to repeat it? Okay. All right, so let me check for an example that we did last week. What was the example for? What was the example that we did, which was having the 6 somewhere? The first example on completing the squares.
The first example,
Yeah.
3q squared is minus 3.
No, the next one.
C or 6c squared plus 18 equals 0.
No, the next one. The one which we are having 6 somewhere here, 6 at this side, 6 something, 6 x, 6 plus x squared. Do you have something like that? Okay, let's do an example on that we did last week, which was the q square minus q all over 4. Okay, so we say we want to complete this square. A plus b square is similar to a square plus what? 2ab plus what? B square. A minus b square equals to a square minus 2ab plus what? Plus b square. So we want to create a pattern which is like this, which is giving us something like this. So we want to form this, yes, or this one when we have an expression like that. Okay? So how can we use this pattern over here to form this one? Okay? So how can we do that? So here, when you look at this, then because of this minus sign, then it is similar to the next one. So it will be like q square minus what? Q all over what? All over 4. So we are looking for the b over here. So we are looking for the b square. So what will be our b square? Now, if you come here and look at this 2ab, yeah, then what can I say? So so it will be like q square minus, because we take the 2, if we put the 2 here now, and then we now know a to be equals to what? Q, okay? So we know a to be equals to Q. Then we have the 2, so it will be 2, we know a is what? Q, right? Right? Now, we have the 1 over 4. So we have the 1 over 4 there. Now, what will remain here, so that when we multiply there, we'll get 1 over 4 here. What will remain? So it is 1 over what? 8, right? So we have now 1 over 8. Okay? So that means we have the 2, which is this one, and this. We said the Q is what? Is A, which is this one. Okay? And now our B will be what? 1 over 8. Our B will be 1 over 8. Now, what will we put here? So it will be what? So it will be plus 1 over 8 because we have known the B to be 1 over 8, and then you do what? You square, right? And then you square. So now what can we see from here? So we've seen Q to be what? Because we use this. Now we know that Q is what? A, right? Now our B will be what? 1 over 8. So this will now be Q minus, because of this minus 1 over what? 1 over 8. And then you put the square. Is that clear? Is it clear?
Yeah.
Yeah. So you do it like that. Okay, so now how can we solve a quadratic equation using the completing squares? So how can we solve the quadratic equation using the completing squares? Now, if our quadratic equation is of this form, ax squared plus bx plus c equals to 0. If our quadratic equation is like that, then by use of completing squares, so if this is quadratic where a is not equals to 0, okay, where a is not equals to 0, then it becomes a quadratic. Now, if you want to use the completing squares, then we make coefficient of x squared to be what? To be 1. So you should let the coefficient of x squared, which is now a here, to be equals to 1. So you should make a to be equals to 1. Okay. So when you make a to be equals to 1, then that means you divide everywhere by a. So it will be ax squared plus bx plus c. All of this by what? By a equals to 0 over a. So what you do here, you must do it in the other side. Okay. So when you divide everywhere by a, then you get x squared plus b all over ax plus c all over a equals to what? Equals to 0. Equals to 0. Then after doing that, yes, then the variables, you put it in one side, and then the constant, you put it in the other side. That means where there is x, you put it in one side. Okay? So x, this x, where you have the x, you put it in one side, x squared plus b all over ax. And then the constant, this constant, you take it to the other side. So equals to minus c all over a. You put it in the other side. Okay? So that is how you can now, and then now using the method that we have done, yes, what we have done, then you now complete these squares, okay? You now complete these squares, and then after completing this one, then you now get the values of x and the values of x. So, for example, so we have an example here. Two m squared plus 2m plus 34 equals to 0. Use the completing squares to solve that. So what do you do? First of all, you make, so step number 1, make coefficient of x squared to be 1. Okay? So you divide everywhere by 2. So what do you get? You get m squared plus m plus what? Plus 17 equals to 0. Equals to 0. Then ones which are having the variable, you put them in this one side, and then the constant, you take it to the other side. So m squared plus m, you take the 17 to the other side, equals to minus 17. Equals to minus 17. Okay? Now, so our next step is so after doing this, let's say after let's say we have x squared plus now bx plus c equals to 0, where now x squared plus bx, then you take the constant, equals to minus c to the other side. Okay? Now, to complete our squares here, okay, then what do? To complete our squares, then we have the x squared plus bx, okay? And then what are we doing here? We were multiplying by the half of what? Half of b. So times half of b, and then you do what? And then you square. Half of b, and then you square. So you multiply by half of this b. The coefficient of x, you multiply by half of the coefficient of x, and then you square. Now, after multiplying by half the coefficient of x, now it will be of this form because of this plus. So it will be of the form a plus b, and then you do what? You square. So you now take this, which is now x is a, and then plus this, the whole of this, which is inside here, will be what? Will be here. So 1 over 2 b, and then you do what? Then you square. Okay? So, so that's how you do the completing squares here. Now, when we come back to this equation, m squared, so we have m squared plus m equals to minus 17. Now, using the same method here, then m squared plus, now our coefficient here is what? Our coefficient is 1, right? So plus m plus 1 over 2, have that coefficient of m, which is 1, and then you do what? You square, equals to what you've done here. In this side, you do it in the other side. Equals to this constant, which is minus 17, plus this 1 over 2, and then you square. Because what you do here, you do it in the other side. You can still remove this by subtracting. They will still cancel, and you will still remain with this. Okay? And then now, you write this one in completing squares form, which will now be in the form a plus b, and then what? Square. So you write this one in this form. So a will be m plus our b will be 1 over 2, and then you do what? You square. And then you square. Equals to what? Equals to this 7 minus 17. And then you simplify this one. Plus what? 1 over 4. Okay? So minus 17 plus 1 over 4 is what? So if you put here 4, 17 times 4. That is minus 68 plus 1. So you get m plus 1 over 2, and then the square equals to minus 67, huh? All over 4. Minus 67 all over 4. Minus 67 all over 4, right? Then, because we are looking for the values of m, then what do you do? Because this one is square. So what can we do from there? So we use the square root property, right? So we get the square root of this. We also get the square root of that. Now, the square root property, if you remember the square root property, so the square root of, let's say, a equals to plus or minus k, right? So the square root of a is the same as plus or minus k, right? So if you get a square root of this, so it is similar to plus or minus there. So plus or minus this one, okay? So finally, because the square root of this is, it will cancel with this square here, then we have m plus 1 all over 2 equals to plus or minus the square root of minus 67 all over what? All over 4. Okay? So finally, our next step is m plus 1 over 2 equals to plus or minus. We have the square root of 67, minus 67. And then we have the minus 1 there. So it is the square root of minus 1 times the square root of 67, which is equals to what? I, the square root of what? 67 all over what? The square root of 4 is 2, all over 2. Now you take the 1 over 2 to the other side. So m equals to this 1 over 2. When you take there, you get minus 1 over 2 plus or minus I, the root of 67 all over what? All over 2. That is our solution. So we have two values there. So we have m equals to minus 1 over 2 plus that, or m equals to minus 1 over 2 minus that. Is that clear? All right, we can do one example. Okay, let's do one example here. Solve 4q square minus 2q equals minus 65. So they have already taken the constant to the other side. So what do? First step is make the coefficient of q squared to be what? To be 1. So you divide everywhere by 4. So it will be q squared minus, when you divide this one by 4, you get 1. So q over 2 equals to minus 65 over 4. So what is our next step? So our next step is completing these squares here. In here. So this is in the form of, so this one is in the form a minus b squared because of the what? Because of this minus here. Okay. So what is our b? What is our coefficient? So our coefficient there is 1 over what? 2, which is minus. So what do you do to get the coefficient? You halve it so that you can put it here. So half of this times 1 over 2. And then you do what? The square. So it's like q squared now minus q all over 2, half of the coefficient of q, which is plus 1 over 2. The coefficient of this one is minus 1 over 2. Then you do what? Then you square. Then you square. Equals to what? So what you've done here, you do it in the other side. Equals to minus 65 all over 4 plus half times minus half squared. Half times minus half squared. Then now write this one in this form, in the form a minus b squared. So it will be u minus what? This one is 1 over 1, 1 over 4, minus 1 over 4 there, square, equals to this, minus 65 all over 4, plus, now 1 over 4, it will be 1 over 60, 1 all over 60. Now, after you're done here, you can simplify this. So you simplify this one. So you simplify this like what you've done in the other one. Then after simplifying, use the square root property. So you now get the square root of this, and then you get the square root of this. And now here will be the what? Plus or minus. So you get q minus 1 over 4 equals to plus or minus the square root of 65 minus 65 over 4 plus 1 over 16. Okay, so when you go home, you can go simplify this. Then, after you're done with that, then you now take the 1 over 4 to the other side. So q will be equals to, so when you take the minus there, it will be 1 over 4 plus or minus the square root of minus 65 all over 4 plus 1 all over 16. And that is our solution. That is our solution. Now let's come to the next section, which is section 6.3. Section 6. So now using quadratic equation using quadratic formula. So this is section 9.3. So using the quadratic formula. Now we can formulate a quadratic formula by use of completing squares. So if you have the equation of this form, ax squared plus bx plus c to be equal to 0. So how can we form the quadratic formula? From this, using the completing square. Now, how do you do the completing square? First, you do what? You divide everywhere by the coefficient of x squared. So you divide this one by a, by a, by a, by a. So what do you get? X squared plus b all over ax plus c all over a equals to 0. That's step number 1. Step number 2, take the constant to the other side. Take the constant to the other side. So x squared plus b all over a x equals to minus c all over a. Then now, looking at this, this is of the form a plus what? B squared. A plus b squared. Now, so what do we get here? What do you put here? So x squared plus b all over a x plus, now what do you put here? So what you do here, you do it in the other side. So we multiply by half the coefficient of x. And the coefficient of x is b all over a. So half that b all over a. So half the coefficient of x, which is b all over a. And then you do what? You square. Okay. So what you do here, you do it in the other side. Okay. So equals to minus c all over a plus b all over a, half of this. So when you take half of this, what do you do? So half of this one, yeah. So over 2, and then you do what? You square. Then you square. So now here, so x plus b all over 2a square, yeah, equals to what? Equals to this one now, minus c all over a plus b square all over 4a square. 4a square. Okay. So we can get the LCM of this. So x square, x plus b all over 2a square equals to, what is the LCM here? LCM is 4a square. So LCM is 4a square. So 4a square divided by a is what? 4a times minus c is minus 4ac. Okay, minus 4ac. And then this and this is 1 times b square is plus b square. Plus b square. Now, using the square root property, then get the square root of this, and then we get the square root of this. And then here we put the plus or minus. So we have x plus b all over 2a equals to plus or minus the square root of. So we can swap this, b square minus 4ac all over what? 4a square. All over 4a square. And then now we take this b to the other side. So x equals to, so minus b all over 2a plus or minus. Now the square root of b square minus 4a all over what? All over 2a. Because the square root of 4a square is 2a. Now finally, x equals to minus b plus or minus the square root of b square minus 4ac all over what? All over 2. This is our quadratic formula. That is our quadratic formula. So quadratic formula is the most accurate one, and we can use this in any other equation, in any other quadratic equation. Now, here, this formula, we have this b square minus 4ac. The b square minus 4ac, which is this one, is what we call the determinant. Discriminant, sorry. Discriminant. This is what is called discriminant. So it determines what kind of solutions are we going to get from the quadratic equation. Now, if b square minus 4ac equals to 0, so there are three things here. One, b square. Number two, b square minus 4ac is greater than 0. And then number three, b square minus 4ac is less than 0. That means if this one is minus, if that one is minus, then what kind of solutions are we going to get? Now, if b square minus 4ac equals to 0, we will only get one solution. Now, if this is equals to 0, yeah, so that means x is like if it is x plus 1, then the value, if this is 0, looking at this, if this one is 0, then what do you get? You only get x to be b over what? 2a, right? So we only get one solution. So we only get one value of x. If x is greater than 0, if now this one is greater than 0, b squared minus 4ac is greater than 0. So here we will get two solutions. And these solutions are real. So these are real values. Two distinct solutions. Now, if this one, if b squared minus 4ac is less than 0, that means they're in the negative side. So therefore, there are two solutions, but they are what? They are complex. So there are two solutions, but they are complex. So they are complex. All right, so we will come and finish on Friday, then we do the applications of that. So before you go home, any question? Carlos, Benjamin, Gregory, Ashley, Victoria. Gregory is here, you can see. Ashley, Carol, Rachel, I can see her, Bailey, Laura, Adam, Kavehi, Andrew, Destiny, Abby, Aliyah, Desma, Jillian, Martinez, Remington, really, Eric, Rock, Thompson, Samuel, Walkman. If you don't have any question, then let's meet on Friday. I will send the solutions for the exam 2 and then the quiz on Friday. Okay. You too. Who else is watching the YouTube? All right, see you guys.